So now let's hand over to Dima, and she can talk about her work at Bristol.
Thank you very much, Peter. And indeed, those were two very good presentations. So you probably wonder why somebody from a university is talking about deployment of private networks. And because we are university researchers, and the common perception is that we are not doing deployments. And this is because actually this is due to the skills and the interest of my research center. So I'm quite privileged to lead a research center called the Smart Internet Lab, which is a large place, about 100 academic and researchers. We are based at University of Bristol, and we are having expertise across optical, across wireless, IoT, and cloud technologies. So a group of amazing experts working in this field of communications and networks for a very long time. So in terms of research, we are doing research on enabling technologies, on systems and network services and applications. And our remit as an academic research center is always to look at the next step. Not what is deployable now, but what is becoming important that is going to be deployable in the mid-term or even in the longer term. Our holistic approach as a center is on end-to-end networks and end-to-end networks design and optimization. And for this, we have expertise on hardware, on software, and co-design of hardware and software. And this is where the relevance comes. We are actually, for 15 years now, we invested quite a lot of our time in what we call real-world deployments, large-scale experimentation or experimentation in the wild. And we started our activity on that, on future Ethernet activities in large consortia within EU, where we put together the first federated testbeds for future Ethernet experimentation. But more recently, we have been very much involved on 5G research and innovation, and that is within Europe, within the 5G PPP program, but also within the UK, within the 5G testbed trial programs, and looking also some early open run private test networks. So we have really been working putting testbeds together and interacting with users and other researchers as places where we can actually address end-to-end problems of networking, complexity, heterogeneity, and we have a rather large activity on that. So here I summarize the actual private, specifically 5G private network pilots. I'm not going to go to future internet testbeds that we actually put together with mainly UK government funding, DCMS funding, since 2018. So our campus network is a 5G private network. So we are doing quite a lot of our initial installations and trials within our university campus, which, by the way, is in the center of our city. So it's an urban environment itself. We have put together a city scale network as a private network for urban experimentation. We have worked with local manufacturing activities like the National Composite Center, and I'm going to talk to you a little bit today about deploying a private network in an advanced manufacturing plant. We have actually put a 5G network, a private network, in our neighboring city, Bath. So around the Cathedral Square and the Roman Baths, that is connected back and utilizing core services back from our Bristol environment via fiber. But this is, for instance, where we looked the use of 5G services for tourism and museums and venues and so on. And like everybody else that talked today, we are engaging with our local port, and we are looking at port logistics and maritime maritime use cases. We have also created a unique capability to connect, to be able to connect automatically with testbeds that are existing elsewhere in the country. So we have connections with London, and you see two instances that we are connected to London here, like King's College and the Digital Catapult, but also we are connecting with places like, for instance, Strathclyde, Leeds, Liverpool, Lancaster, and so on. It is impossible to talk about all this, but the whole purpose actually of our private network activity is to look how by creating these networks we can engage with vertical sectors and look at the adoption of 5G in different sectors and different enterprises. And what you see here, for instance, engagements with some of the sectors that we had, smart city, ports, and specifically free port zones, transport, logistics, manufacturing. We looked at security and assisted living. We looked at robotics, especially collaborating with the Bristol Robotics Lab, smart tourism, digital media, music and sport, public safety, connected homes, and the list goes on and goes on. But the thing is that by putting together these private networks, we are opening up that capability to collaborate, co-create, and innovate with the vertical sectors and understand what kind of services these sectors would need through private networking in order to drive their use cases, but most importantly, to drive digital transformation within their sectors. So here is the first private 5G private network that we put together with DCMS funding back in 2018. That is an urban environment. That is the central square, one of our central squares at Bristol. And this is called the Millennium Square. And this was, when I'm looking at it, back in 2017, 2018, it was really a challenge, but now it looks like a small and simple private network. What we have here, we are having actually an outdoors environment, the square, and the indoors environment in the Science Museum that you see in the end of the square. We took the stand from the beginning that actually 5G is a network of networks. So we have, of course, 5G, some of the first UK 5G pilot deployments working with Nokia in this particular case. But also we looked and we incorporated within our private network 4G connectivity, Wi-Fi connectivity, integrated seamlessly across all the way from Wi-Fi to 5G services. And we have plenty of fiber. So we used a mix of fiber backhaul services, but also millimeter wave. Somebody mentioned 26 gigahertz. We have deployed and we are deploying 26 gigahertz for backhaul here. And then we looked into the future. For instance, in the indoors environment, we had the UK's first installation of visible light communications for connectivity. And in this case, you see, we install Li-Fi for indoors connectivity. Just to give you some idea, this is the reach of our urban private 5G network. And this is the center of Bristol. So you can see multiple locations that we are addressing now, mainly innovation centers and museums. Our AR, VR labs, where actually they are hosting the creative communities at Bristol and a lot of gaming SMEs. And you can see here the locations and the extent of the network, and of course, the connection into the Roman baths connected via fiber, as I mentioned before. So really, although you have two locations, you have the same private network instantiation in both locations in this case. Quite a lot of what we are doing, we leverage on very rich fiber environments. So fiber services for connectivity are across the different sites. And of course, we extensively are using flexible fiber backhaul technology in all our networking or most of our networking solution. So you can see here our fiber assets. And this is when I say our fiber assets, this is really assets that we acquired and we installed through my research center, Smart Internet Lab. And what you see here is actually the mobile network coverage for our smart city, for our urban private network. This network is open, is being used since 2018 extensively, and has been used by a number of stakeholders. I mentioned before digital creative, so our content developers at Bristol and our gaming community. So this is a very big industry here at Bristol, and it was the first actually vertical sector and innovator sector that we collaborated with. We work, this testbed is being used extensively by our local governments, for instance, for public safety. Trials are connecting at the moment surveillance cameras at the Bristol Harbour site, and is being used for actual trials of connected transport, autonomous transport, and so on. It has a life on its own. I have a team that is actually operating this network, but is really very open for all the innovator communities within the center of Bristol, that they actually would utilize this private network and develop applications or trial technologies that they fit with 5G networks, and especially with the private network agenda. Some of the features, we try to make this as open as possible in order to actually host innovation all the way from the physical layer up to the software layers. So we actually deploying a lot of open source software and hardware platforms in terms, for instance, man orchestration. The whole network is SDN control with open platforms. We have open MEC solution within this, which aligns completely with ETSI standards. We have open platforms for monitoring, analytics, and network metrology, AI and ML tools, and also we have open hardware platforms with a form of programmable FPGAs, especially at the edge of the network. So we allow actually innovation and programmability and solutions to be hosted on hardware as well. And of course, we are complying with standards, fully 3GPP LTE advanced and 5G new radio. We have Wi-Fi 6, we have fiber access, WDM PONs. And for transport and core network, I mentioned before, we are using a lot of fiber. We are using EPC over MEC. We have no standalone 5G systems and standalone core. And now we are supporting platforms of virtual MEC and also Open RAN for both 5G and, of course, 4G Open RAN. We have done it about 1.5 years ago. So some capabilities, we are multi-site, we are multi-vendor, we have multi-vendor hosting capabilities, so a vendor can come and they're coming to put their boxes, and we have a lot of vendors from Europe, for instance, like Accelerant, that they're deploying and trialing within our network. We support white box and open software platforms. We have multiple mobile packet cores from EPC all the way to standalone packet cores. We are working on licensed and unlicensed spectrum bands. Steve mentioned 3.5, 3.8 to 4.2. We are also working on higher frequencies, 26 gigahertz and 60 gigahertz. We are connecting our networks with urban and enterprise IoT platforms so we can leverage data and actually perform using IoT infrastructure for intelligent operations within the sectors. We have very engaged users, and our users span from industry to researchers to local government to vertical sectors to public. We are measuring user experience and sector experience out of the services that we are providing. And most importantly, and that's very important when we are looking at private networks, we are developing systematic methodologies for co-creating with our users and our sectors. Now, I'll go quickly to two other things that we are involved in, and actually we are making significant technological contributions because exactly for this long-standing experience that we are having in deploying and using and opening up private networks. The one is the 5G and Code project. This is funded by the 5G Testbed and Trials program within DCMS. And this actually is looking how 5G is going to transform digital engineering and especially advanced manufacturing sectors. I'm not going to go through all these things, but this is a large project compared to other 5GTT funded projects, and is looking to deliver a private 5G testbed within the National Composite Center in order actually to look at new business models and increase efficiencies in manufacturing. You can see there the initial partnership. In this initial partnership, I'll go very similar to what Steve mentioned. You hardly see recognized 5G vendors. And the reason for that was because the project took the the actual position that we are first going to understand what 5G private network for advanced manufacturing is going to look like, and then we are going actually to acquire technologies from vendors to fit the requirements and the design. So 3 use cases. The first one is actually asset tracking within the factory. So really look how we can improve productivity and reduce cost by providing accurate and live location and condition tracking of the assets. That appear to be a very big problem, especially when you are looking at advanced manufacturing and specifically in this case, composite manufacturing. The second use case is 360 video training. So how we can improve actually efficiency of training and also trainee satisfaction when we are using advanced VR 360 platform, 360 degrees platform, in this case for the use of 5G mobile networks in manufacturing. And then closed loop manufacturing, in this particular in liquid resin infusion, that is a composite material. So how we can automate processes in actually manufacturing of composite materials. So those are the 3 cases, and they go from logistics to training to manufacturing, automation manufacturing, because these are the specific cases that this sector highlighted as being their biggest blockers. And the things that they would like first to solve as they are going towards digital transformation. Now, one key to this, so this particular one, it has 3 sites and actually 3 distinct private networks per site. In the beginning, the idea was actually to deploy virtual private networks. So actually to have run and MAC in each of the site, but packet core to be able to leverage from a public network operator. You can see the sites through national composite manufacturing sites that they're quite close to each other. And then what you see here, we are also have a public site in the center of Bristol to be able actually to demonstrate to the public and do events, which actually we can demonstrate how composite manufacturing is happening. This composite manufacturing is actually serves the aerospace industry here in the Bristol region, and is one of our biggest industries. So there's a lot of public interest as well, how we can support and enhance that industry in our region. So this is, so you can see here we have 3 use cases, and the idea is that we want to provide a virtual private network for each of these use cases. So the one part of the technology we're deploying is really slicing and being able to provide a secure and flexible slice to each of the use cases that we are supporting. We also would like to have cohesion and be able to provide end-to-end services across the 3 sites. So the 3 sites, the private networks, they are connecting through Telefónica's 5G public network. But as I mentioned before, Telefónica is not providing a core service. The core services packet core services are hosted within the individual networks. And you can see here the 2 NCC slides are connected via millimeter wave network, while actually the NCC sites with the center of Bristol are connected by fiber network. So the lead of this project is UK SME and the university spin-out called Zeta Networks. They are providing the slicing solutions, and then on top of that, they're providing what they call a splicing solution, which actually is able to chain different slices in an end-to-end environment. And this is a key innovation for this project, and actually quite a big opportunity of actually extended private network environments when they are geographically dispersed, while actually we maintain the integration of service provisioning across multiple private network environments. Where this project is getting now into its final stage. So at the beginning, they implemented a 4G network, private network. Now the project is moving into a 5G standalone network delivery, which is due to be commissioned in August and then delivered for demos in October. What you see here is actually the technology partners that they are involved now. And you can see, for instance, partners like Airspan that provides the RAN solution, Druid, the core solution, and then Adva, Juniper, EdgeCore that they are providing actually the backhaul and the MEC solution into the mix. I realize that I don't have much time and I want to move into the next one. That is a project 5G logistics, and Steve mentioned, so it's a project that actually is looking, the logistics involve Bristol, the ports at Bristol and the highways, the motorways between ports, smart junctions at M4 and M5. And what you see here is actually we are having the port, and you can see that in the far right, which we had the ambition to become Freeport. So we start thinking about this when we were putting this project proposal forward. Unfortunately, Bristol has not been actually recognized, funded to become a free port, but still actually the use cases we're developing are very relevant. So we have a port and we have an innovation zone, the free zone that you see on the other side attached to the port. And then we are having actually a junction in the motorway that actually connects and brings assets into the ports, into the free zone, and actually facilitates the interconnection between the two. The use cases that we are supporting here is around security, around traceability and tracking of goods within and across the boundaries of these environments, and also between private and public networks. So Steve showed this diagram as well. So you can see the two environments here. You can see the port, the Bristol port, where actually we are hosting 5G private RAN. We are hosting a core, and that is AutoCore solution, and we are hosting a MEC solution. So this is where we are actually hosting our packet core. And then we have the free zone, which is the Gravity, is an innovation campus associated with port operations, where we are having private RAN and MEC, and actually packet core services are being provided with the port environment. And you can see also the smart junction connected to this, where actually in the smart junction we have RAN. And we are running a different services on top of this. One of the services, for instance, is freight asset monitoring. So asset monitoring within the trucks. So we have freight operators that they're providing vans and trucks. We are providing services in terms of geolocation services and security services. To go to this very quickly, those are the key innovations that we have actually initiated in this project. So IoT transport, and we're relying quite a lot of IoT and IoT mobility for the asset tracking, especially asset tracking on the move. We host AI on premises, so each of the premises is hosting a MEC solution with bespoke AI tools and services within this. 5G location tracking, so about centimeter accuracy in our tracking, and actually network security to secure operations within the port environments. And I would like to actually finish with this slide, and I know that probably I've gone very quickly, so apologies, just of the key ingredients and key innovation areas in terms of actually private networks as we go forward. From what we have seen, private networks, they're never going to be pure 5G. Most of the sectors, they would like to utilize assets that they have installed already, and actually services that they are already receiving. So multi-access is very important, and multi-access associated with mobile edge computing, where it's going to give the the capability to develop bespoke customized services for the actually venue that or environment that we are deploying the private network. So that multi-access and mobile edge computing in coordination is very important. The capability to use both wireless and fiber backhaul in a flexible and elastic way is another important thing. Network slicing and service orchestration in order to facilitate customization, multi-tenancy, and in sometimes resilience and security of the infrastructure. But the most important thing, and I'm going to close with this, I have completed my time, is actually private networks are all about the users, all about the individual sectors. So considering very much the user needs, co-creation with the users and the sectors involved, and actually involve sectors and venues into the innovation cycle. Those are the 4 areas that I would like to propose to take forward where we are thinking actually evolving private network environments. And thank you very much. I close here.